So SQLMap is a free and open source tool for detecting and exploiting SQL injection. It is often labeled as a script-kiddie tool, but today I want to change that perception. I will show you that SQLMap is far more advanced than most people think. Many say manual exploitation is better, and yes, it is essential to understand how SQL injection actually works, but manual testing has its limit. In this video, we will use a try-hack-me lab mainly because of the type of injection involved. This target isn't error-based, meaning we won't see any SQL error message when we send our payload. Let's start Burp Suite, enable the proxy and intercept the request. I will send it to the repeater to manually test if the application is vulnerable. For example, I will replace the parameter with %27, which is the URL encoded version of a single quote, then send the request. If it were an error-based injection, we'd expect to see an SQL syntax error in the response, but here, nothing changed. And that's the first challenge of manual testing. You will often have to try dozens of payloads to find one that will work. To save time, we will automate the process with SQLMap. But before we do, we need to give SQLMap as much information as possible, not just a simple URL. There are two main ways to do this. The first is through your browser network tab. You can resend the request, inspect the parameter, in my case the blood group A+, and even copy it as a curl command. You could then pass that into SQL using the flag U option. But the cleaner and more reliable method to do is to capture the request in Burp Suite and save it to a file. Once that's done, you can run the -r command and let's put the DBS flag. And just like that, the database is compromised. On a simple example like this, SQL might look like a beginner toys. But let's go step deeper to see what it's actually doing behind the scene. We will rerun the command with the verbose mode enabled. Now we can see every detail, how many requests are being sent, which payload are tested, and what SQLMap detects. It automatically identifies the backend database management system and chooses the right injection technique. In this case, this is a time-based blind injection, meaning there are no visible errors, only difference in response time from the server. Believe me, reproducing that kind of logic manually will take forever. That's where SQLMap really shines. Of course, not every injection works on the first attempt. And that's exactly why SQLMap is not just a tool for beginners. It's a complete framework, packed with documentation and advanced options that help you deal with almost any situation. Two of the most important are the level and risk. The level option tells SQLMap how deep to go in testing. There are 5 different levels. Level 1 only checks get and post parameters. 2 will add cookies. 3 will include headers like referrer and user agent. 4 will try more aggressive payload, and 5 even target the host header itself. The higher the level, the more payload are tested, from about 100 at level 1 to more than 1,000 at level 5. It takes longer, it is more intrusive, but it will increase your chance of finding hidden vulnerabilities. The risk option defines how dangerous the payload can be. Risk 1 uses safe, read-only payload that shouldn't modify the database. Risk 2 introduces slightly more intrusive payload, but SQLMap includes safeguards to minimize damage. Risk 3 uses payloads that can alter the database or even crash the service. If you're not sure what you are doing, don't use Risk 3. In most bug bounty programs, for example, it is explicitly forbidden to run destructive tests. So always think twice before using higher risk level. SQLMap can also map the entire database scheme. Once mapped, you can search for specific keyword. For example, table containing the word user. This search function can save you an incredible amount of time during reconnaissance and exploitation. And yes, in real-world engagement, most web apps are behind a firewall or WAF. SQLMap gives us Tamper script to bypass this protection. You can list them with the list Tamper flag. For example, we can encode our payload in base64 using the appropriate Tamper script. Now, every payload sent by SQLMap is encoded, helping you bypass filters that block SQL keywords. And that's just scratching the surface. SQLMap offers many other advanced features, from OS command execution to file reading and custom injection point. But that's for another, even more detailed video. If this one helped you see SQLMap in a new light, don't forget to subscribe and like the video. It will really support the channel. Thank you for watching, and I'll see you on the next one.